Okay, thanks for that introduction, Nandadeep. And it's really exciting to be a part of Pune Tech community. I mean, delivering this session, it's really my honor. So more than thanking me, I should be thanking you to give me to have given me this opportunity. And good evening, everyone. I really appreciate you all are putting your Friday evening into this. Um, I hope you will gain something out of whatever I have gained in the last 5 years of so that I have been into AI ML and lately into generative AI. So as Nandadeep said, Nandadeep and I were together in our first job. So we started around 20 years back, and we I'm meeting Nandadeep almost after 10 years now. And yeah, for the last 5 years, I've been into mostly into AI and ML space. So what I will be doing now is, as I said, mostly it will be around the generative AI space. So these days we hear these words a lot, right? Generative AI. Everywhere we see Chat GPT, generative AI, all these terms being called. So the main idea is that what exactly is generative AI? How is it actually disrupting the industry? And what are the applications beyond ChatGPT? So ChatGPT is something we do play around. Everyone loves to play around. But what is the value that enterprises are trying to bring out of that? Secondly, there are certain techniques like um, say content generation or retrieval augmented generation. What are those? So we will be having a look at those now. So I hope my screen is visible to everyone. With that, I will begin. So at a broad level, this will be the agenda. What is generative AI? What is language model? Types of LLMs? All of these. By the way, just feel free to stop me and ask me any question in case you anything is not clear. Okay. All right. So let's begin. So what is the AI perspective? So when I got into the AI field about 5 years back, I had this major, I would say, roadblock when I would try to understand how AI works, because I had almost 15 years of experience in the traditional software development. So I was working in .NET technologies. I was a web programmer. I used to work in SharePoint development, which is all very logic based. So if you just so all the traditional software developers here will agree with me that say .NET, Java, all of these are very logic based. You have if, else, for, and int equal to I and all that. So when I came into artificial intelligence, it was I really required a shift in my perspective in whenever I would do the development, because traditional software development is more logic based. That is what I was conditioned on for the last 15 years. Whereas artificial intelligence based solutions are all pattern based. So essentially in AI, you do have if and else conditions and all that in Python. But what AI essentially tries to do is it tries to find a pattern in the data that it is given. So in very simple terms, there is some historic data based on which the AI model will try to learn the pattern, and then it will try to predict the outcome, right? In very simple terms, let's take a very basic example. Let's say there is an employee database wherein we have some columns for that table. In that employee database, we have a column, we have a table called employees, which has some columns like name, age, gender, marital status, number of years of experience, skills. There could be many more. So all these columns, what we call, they are nothing but the dimensions. We call them as dimensions. And at the end of there is a dimension called salary, right? So for a given person with at a given age, with certain skill set, at a given level of experience, he or she earns x amount of rupees every month, right? That is a salary. Now if I give the details for another person and I try to see what is the salary, probable salary of that person, what AI model tries to do is it tries to find the pattern that okay, generally it is observed that people with say 10 years of experience in AI earn say 10 lakh rupees per annum, whereas the same level of experience a Java developer earns 8 lakhs of rupees per annum, right? So these are certain patterns that the model identifies, and accordingly it tries to predict. So based on all the dimensions that are given, maybe the skills and the level of experience, those dimensions influence the most on the salary, and that actually happens, right? So these things, these relationships between the different dimensions of the data are automatically identified by the machine learning model. So there are certain techniques to do that. There are certain statistical algorithms to do that, which can be which for which there are a lot of resources also available. And 1 hour won't be sufficient to cover all of those. But at a broad level, that is what is machine learning, right? Now, coming back to this, traditional software solutions have very clearly defined rules, whereas AI-based solutions are mostly learned and discovered relationships, right? There is nothing explicitly mentioned that okay, skills is having the maximum impact or influence on salary, or number of years of experience is actually influencing the salary the most. No, it is something which is discovered. It is something which is learned by the algorithm, by the model on its own, right? There are techniques to do that. The most important thing is traditional software solutions are all deterministic, whereas AI based solutions are all probabilistic. Now, what I mean by that is that in an AI solution, you will never get a solution that is 100% accurate. Suppose there are two words, big and large, right? Now, from whatever English we have learned since our childhood, we know both of these are synonyms. They mean the same, or small is always less than big, right? But when a machine learns this through natural language processing, it will never predict 100% that big is equal to large. It will always have a probability associated with it. That it tells that, okay, this, this is the result, but with a 74% or an 80% confidence. Confidence in the sense that is probability, right? So generally what we do is, let's say a very simple example is we are trying to identify whether an image is that of a cat or a dog, right? So the machine learning model is already trained to identify or predict whether this is a cat or a dog. We supply it with an image of a cat. It predicts that this is a cat. Okay, that is a correct prediction. But in the background, if you see, it has predicted that to be a cat with a 75% or an 85%, or there will be some number, that percent of probability. What that means is that the model thinks that the image that you have given looks like it is a cat. It can also be a dog. 15% I feel it is a dog. 85% I feel it is a cat. That is why it is a cat. Okay. So in every AI solution, we define a threshold that if you have the probability, say above 70% or above 80% or above 50%, then you should classify that to be the probability which is above 50%, right? So in reality, what happens is that this is particularly meant for the customers whom I regularly present. So most of them have this conception that AI is, it can be 100% accurate and it will do all my job. No, it is here to help you with some productivity benefits. Um, it can never replace humans, but it can help humans in reducing their efforts or time, right? It is always an evolving solution, and there are too many determinants. Just as I said that, for example, the salary example that we took, we only talked about say 5 or 6 dimensions. But let's say you're trying to predict whether a person will say purchase a credit card or not. There could be hundreds of determinants, there could be hundreds of dimensions into that structured data, and those have to be learned, right? uh, okay, so machine learning and applied machine learning, what is the difference? So machine learning means this is more of a study of the inherent trends, whereas or whatever I have described so far, all of that is machine learning. Applied machine learning particularly means that when we try to apply these machine learning principles, or when we try to apply all this theory into some practical business, into solving some practical business problem, that becomes the applied machine learning. So typical machine learning is more research oriented. So there are PhDs and there are researchers Generally, this work happens maybe in the likes of Google Brain and Tesla and all these companies. Mostly what we do in service-based companies are all business solution oriented applied machine learning. So we simply identify a problem for the customer and we try to solve that using machine learning. So that is the difference between machine learning and applied machine learning. Now coming to what is generative AI. So at the very top level, at the biggest umbrella is artificial intelligence, under which we have machine learning. We even have reinforcement learning, and there are other techniques. But for the sense of brevity, let's consider this machine learning. Beyond within machine learning, we have deep learning, and within that we have generative learning, AI. Now, we saw what is machine learning. Now, what is deep learning? What happens is that, let's say the example that we took either for salary or for predicting the credit card churn, we have only considered data that is tabular, or what we call as a structured data, the data that we get in columns and rows. But what for data that we get, something like images or say free flow text, right? A Wikipedia article, for example, even that is data. Even that has a lot of value into it. Even that has a lot of, the substance is very valuable, is very rich, but it is not in the form of tables, correct? Or even images. So it could be an image of a cat or a dog or an aeroplane. You cannot really have a structured data out of it. So whenever we are trying to get some sense out of unstructured data, which may include images, free text, videos, audio, all of that falls under deep learning. Now, for machine learning, generally we have algorithms which are mathematical based or statistical based, right? So typically they will follow a path. For example, as I said, that number of years of experience and the salary, they are both directly proportional to each other, right? So as the years of experience increases, your salary increases, right? So there is a direct relation between that, which is easy to be tracked through some mathematical formula. But how will you know whether the image is that of a cat or a dog? There is no mathematical formula that will define it, right? So in such cases, what we do is we employ neural networks. So neural networks is something which learns the way human brain learns. So whenever we talk of deep learning, we always employ neural networks to it. Now there are different architectures for neural network also. Again, I won't go into the details of it. That would be overwhelming for this. But you can find most of the resources on YouTube, or you can even connect with me offline. I will be able to explain that. Now, a further subset within deep learning is generative AI. Now, generative AI is the branch of deep learning that creates content. So, what kind of content? It could be text, image, code. So, so in case you happen to use Google Colab these days, or you have used GitHub Copilot with Visual Studio, you can see that you can simply give a prompt that a very simple could be write a class for a bank with all the banking operations as functions. It will automatically create that class for you. You specify you want it in Java, C Sharp, Python, any language, it will do that for you, right? Or in Colab, when you are typing the code, automatically gives you the suggestions. That is all nothing but generative AI, right? So text generation, we have all seen in ChatGPT. You give a prompt and it generates the text for you, right? Similarly, we can even have audio, video, although this is in nascent state currently. But yes, text, image, and code is pretty mature now. So any AI that creates new content is generative AI. So when we talk about generative AI, we talk about LLMs, correct? Large language models. Nowadays, they even talk about small language models because those can be deployed on the edge. But what exactly is a language model, right? Language model is an AI model that predicts the next word or the next token, right? And it focuses on completion. Now, what do we mean by that? For every language model, there is a prompt, which is the user input. Now, let's say my prompt is twinkle, twinkle, little. This is my prompt. What is the next word We all know it is star because we all have learned that in junior KG itself. So why star? Why not cloud? Why not sky, planet? What happens is that language model is trained on a very large corpus of text data. They claim that the likes of GPT claim that they have scanned through the entire internet and got all the text data available on the internet to learn from. So just imagine the kind of trends, the kind of the data this language model is trained upon. So obviously it has come across this sentence lot many times, twinkle twinkle little star, the poem. So what happens is that out of all the content, the text corpus that the LLM has learned, just imagine the kind of vocabulary it has. Literally, almost all the words that we have in English language must be there. I mean, the LLM must have gone through those. What happens is whenever it tries to predict the next word, all of those words are given a probability score. Like this. In this case, I have only considered four, but this will be literally all the words that we have in English. For cloud, the probability given is 0.15. For sky, it is 0.02. Planet is zero point 0.8. Star is 0.75. Now, if you add up all of these 0.15, I mean, if I consider percentages, 15%, 2, 8, and 75%, they all add up to 100%. That is one. So, whatever prediction happens, all the numbers are given a probability score, which adds up to one. And out of that, the highest one, which is star in this case, becomes the prediction. So, obviously, for this prompt, twinkle, twinkle, little, the prediction is star. Now, because this focuses on completion, what happens is automatically it adds this prediction to the prompt, that is user input plus last prediction, that is star, and the whole thing becomes the prompt. And then the obvious next word gets predicted in the same way. This goes on, this continues till till it achieves the prompt that we have given it. So let's imagine that you give a prompt to write a composition about my mother, right? So it will follow the same sequence. It will keep on predicting one word at a time and then adding that word into the prompt, predicting the next word. But all of this happens so fast that we feel that it is typing on the fly, right? But in the background, it is all, each word is being predicted as the next word. Okay. So this is the language model. So you must have heard, I mean, in case you must have read about generative AI, they talk about transformers a lot, that it is based on the transformer architecture. Now, what is transformer architecture? Transformers means it is based on attention mechanism. So I think it was 2017 or 2018 when Google Brain released a white paper. It was called Attention is All You Need. That defined the attention mechanism, and there they had discussed, or rather they had invented an architecture which they call as the attention mechanism or the transformer architecture. Now, earlier, what would happen is, for example, in there are other architectures like RNN, recurrent neural networks. A branch of it, or a type of RNN is LSTM, long short-term memory. What would happen is that, let's say this is a sentence: the Prince of England married the Princess of Denmark in a royal wedding attended by the Prime Minister in London. So, in had this been LSTM, LSTM will learn the sequence of the words one after the other in the sequence going forward, right? BERT, that is a BERT, BERT, that is one of the architectures defined by Google, that would do it on both the sides. It will try to learn from left to right, also from right to left. So what it is trying to learn is it needs to predict the next word, right? So that is why it has to learn all the words. But the LSTM will happen sequentially, one after the other. What attention mechanism does is, for every sentence, it tries to find the relationship of every word with every other word. So just consider this. I have listed down each and every word as a column and as a as a row. Now we are trying to find the relationships between each word with every other word. So all of these are not blank. There will be some numbers here also, but for the sake of understanding, I've included only few. So just consider this: the word prince will have a relationship with the word royal, correct? Because a prince is a royal entity. Similarly, princess also has a very high correlation with royal. Now what this point 8 means is, point 8 means a correlation. So in statistics, a correlation is a number that defines the relationship between two entities, right? So the number could vary from -1 to +1. -1 means it is extremely opposite, +1 means it is exactly the same. So over here, the relationship between the word royal and prince is zero point 0.8. That means this has a very high positive correlation, these two words have with each other, right? If there were a word called beggar, so beggar, I mean a royal, beggar and royal won't have any correlation. Rather, this might become minus zero point 0.8 because a royal person generally won't beg, right? Won't be a beggar. So that is how it is. In the background, what happens is that um, this is something which is called as text embeddings. So what are text embeddings? That machines won't understand text. Machines only understand numbers. So embeddings means they give a number to every word, not one number, but it is generally we have special NLP models, natural language processing models, especially meant for embedding. What they mean is that that embedding model might be say of 512 dimensions. That means each and every word is identified by 512 numbers, which are there in a sequence, right? So that is what embeddings. How those numbers are formed, again those are that is a black box for us because that happens within the neural network. But based on the text that it learns, it identifies that okay, there is I mean this word will be defined in this particular set of numbers. That's called as embeddings. Now coming back, if you see, prince has this very high correlation with royal. England has a very high correlation with London, whereas prime minister will have a very less correlation with royal because prime minister is not a royal uh, designation, right? Similarly, Denmark will have a very small correlation with London because London is the capital of England, not of Denmark. So attention mechanism will try to learn the relationship between every word with every other word in a sentence, and that's what makes this very effective as compared to the earlier architectures like LSTM and all. Secondly, this also allows for parallel processing. So you can, I mean, there were some limitations or to, while training the LSTM architecture, but with attention mechanism, that limitation to a large extent has been overcome because of the parallelism it brings in. Now let's talk about types of large language models. We have three types: foundation model, pre-trained model, and fine-tuned model. Foundation models are what we see day in, day out. Almost every week, there is a new model that comes up, right? Latest, I think, was Cloud 3.5 Sonnet. We have GPT 4.0 released recently, about 15 or 20 days back, I believe. So OpenAI has the GPT family, GPT 3.5, 3.5 Turbo, 4.0. Google has the Gemini family. Anthropic has Claude. Meta has Llama. There are lot many more large language models, and they keep coming out every day. So foundation models are the models that are trained on the on a very large corpus, and generally they are trained by these leaders. Even for in India also now, I think Ola is training the Krutrim model, right? So generally they are trained grounds up by all these major players, and it requires a lot of compute, lot of resources, lot of money to do that, lot of time. Now, foundation, those are called as foundation models. Now, what are pre-trained models? On top of foundation models, so some companies train their own models. Now, for example, Bloomberg. Now, Bloomberg has a lot of data of their own, right? So, Bloomberg is Bloomberg is the company that advises, or I would say that provides the resources to all the equity investors or asset managers throughout the world with what is happening in the economic world, what is happening in the industry, how the companies are performing, what are the figures, what are the news that might affect the share price and all that. So Bloomberg provides all of that to global customers. They have a lot of data of their own. So they have come up with some of these. They have just employed one of these foundation models and trained specifically on their data. So what happens is that pre-trained models are good at predicting that particular task. So in this case for Bloomberg GPT, whatever tasks Bloomberg wants it to cover, those will that model will be very specific and very accurate in doing that as compared to the foundation model. Similarly, Google has come up with MedPalm 2. There might be and the next version also now, I'm not sure, but MedPalm 2 is trained on the medical data. So Google claims that MedPalm 2 can um, beat the best of the brains in the world, human brains in the world, when it comes to answering medical tests or medical exams. That's what they have observed and documented. And fine-tuned models are, again, they are fine-tuned on top of foundation models or on top of pre-trained models, but relatively the custom data is very less. So let's say if I want to do something for my own company, I have a very small data, so I would fine tune the model. It won't be as rigorous as pre-training, but rather it will still require some resources, but not as large as those for pre-trained or foundation models. So for corporate specific asks, we can fine tune these models so that they are good at answering our specific questions. So practical applications of generative AI, when we talk about text, image, or code, for text, it is text generation, classification, all of these things, sentiment analysis. For image, of course, image generation, image comprehension. I'm sure you must have used or tried DAL-E. So you can give any prompt to DAL-E. For example, a prompt could be as weird as draw the picture of a cat who is playing a violin on Saturn. So it will come up with that. It will show Saturn in the background, a cat who is playing the violin. And image narration, you give an image to it, it will narrate that, okay, this is the image of a girl who is standing on the beach on an evening, something like that. Code generation, we have already discussed. In our company, we have actually implemented these two projects, code commenting and code translation. So they had our customer had an application in Java that was built, I think in 2015, 2016, something. So the team which built that has already left. There is no one to support it. And the current team is finding it very hard to support or upgrade. So the ask was that we should use generative AI to generate the comments for the Java, the complete application. That's what we are doing. And second thing was about converting an Angular app into React. That also we have done using generative AI. Now, practically, if you see text, image, most of the okay. So most of the what we see work coming, or the use cases being implemented in the industry these days, those are around three or four areas. One is call center optimization. So how can we improve the performance of a call center agent, or overall how can we make that entire experience more productive? So let's say you call a call center and it takes 10 minutes to complete the call to resolve your query. How can we reduce that from 10 minutes to say 3 minutes, right? Maybe we can help the call center agent by identifying the right content from the words that you are speaking, right? Automatically that comes out to him as a suggestion. Or the call notes that happen between the conversation between you and the call center agent, those are automatically generated. So these kind of use cases are being explored. Secondly, in marketing sales also, for very customized emails that you receive, or customized flyers are being created, wherein we have the title, the subtitle, the maybe the flyer content, the email, the image, all of that otherwise a human would do, but nowadays they are employing generative AI a lot. So there they make use of text as well as image generation. Now, these are some challenges with content generation with GenAI. Catastrophic forgetting, that is, if you train the model to a specific task, it will be good at answering that, but it won't be that good in answering the other tasks. Hallucination, of course, it generates any random text. So You ask it to do something and it just simply hallucinates. It starts predicting something else that you're not looking for. Knowledge cutoff, knowledge wise, it is limited only till the time it was trained at. So if GPT-4 was trained, released in July 2022, then it won't know anything that has happened after July 2022, right? And token size limit. So how much is the input token that every model can consume? So generally, the open source models like Llama or Claude, of course, they are free, they are open source, so they have a very limited token size. But if you go for other models, then they are very, of course, those are paid and they offer more token size. So you must have heard this word a lot, prompt engineering. What is prompt engineering? So the skill of constructing a prompt, that is an instruction set in plain English for an LLM that makes the LLM respond accurately and in a format of your choice. So when we talk about generative AI, we want the LLM to generate some content for you, right? But what content has to be generated? Those instructions have to be given very clearly, right? So you prompt engineering is nothing but it is an art. It is more of an art. It is more of a skill than science, wherein you should be able to give very clear instructions to the LLM so that LLM responds to you in the way you want. So typically the components of a prompt are system message, instruction, all of these. We will have a look at it in the next one. So I'm sure you all must have will remember comprehension that we would do in school, right? So comprehension would be like you are given a content, you are given a passage, and you are given some questions. Those questions you need to answer from the text or from the content that you have in the in that passage. So now let's say in this case, I have just borrowed this from the annual report of Hero Motocorp. So this paragraph says about talks about two-wheeler EV market. So electric vehicle. So electric two-wheeler market, how is it in India? What was the penetration in FY 21-22 against 2021 and all of that? So to write a good prompt, I should be first giving it a system message that you are an equity research analyst and shall offer insights into companies' annual reports. Then this is the primary content or the context. So I'm telling the LLM that you need to find your answer from this text. Then the very specific instruction, what is the penetration of electric two-wheelers, and then how do I want that answer to be? Whatever you answer, I mean, I'm telling this to the LLM that whatever you answer, reply it in one word wherever possible, and reply it in tabular format wherever possible, and it should be in short title colon value pipe short title colon value. Now when I run this is what I get as the response. FY 2020-21, this is the short title colon the value pipe title colon value. Now this I can again take this as an output. I can break it up in Python and I can create these graphs out of it. Right? Now typically you might have heard of this word also. Whenever we talk about generative AI, we talk about retrieval augmented generation. Now just imagine all of us enjoy um, chatting on or asking questions to ChatGPT, right? We can ask any question and ChatGPT tries to answer that. Now what if you wanted, or what if enterprise organizations, they wanted to have a ChatGPT like experience on their own data? So let's say there's a company which gets into lot many legal contracts with lot many vendors, suppliers, customers, and all that. They have thousands of legal documents in their SharePoint site or any document library. Now they want to have very specific answers that how many of my contracts are expiring this month, or how many contracts, or tell me the name of the contract with the highest contract value, or list down all the contracts that were renewed in January 2024, right? So just imagine all these contracts are in PDF format, that is unstructured text, so you won't have the data in a structured database, and you still need these answers for the very natural language queries that the user will give. So LLM can actually make that happen. how that happens is that, let's say these are all the PDF documents, the legal documents in this case. There is a concept called document chunking that happens. So chunking is nothing but breaking down the document into multiple pieces. So let's say each document is 10 pages. For each document, we are breaking that document into 10 chunks. Now, why do we do that? Let's say, okay, I will take an example of a book. For example, let's consider the book Harry Potter. Okay, now Harry Potter is a 600-page book. Now, if I ask a question, if I want to know what is the name of Harry Potter's mother, of course, I should not be scanning all these 600 pages to get my answer. My answer could lie on page number 4, right? That is enough. I don't have to go through all the pages, 600 pages, just one page, and it should give me the answer. So what document chunking does is, let's imagine this book gets divided into 600 chunks. All these 600 chunks are converted into vectors or embeddings, what we spoke about. Embedding is nothing but numbers that are given to the text, and all of this goes and gets saved in the vector database. Now, vector database is a special kind of a database. This is not a relational database, but this is specifically meant for saving the text embeddings, right? Now, for one book with 600 pages, we have divided those into 600 chunks and embedded all of those. So this will have 600 different embeddings. Okay. Now, if a user asks a question, what is the name of Harry's mother? That question again gets embedded, I mean, gets converted into a number, and using semantic search. Semantic search means finding similarity between two texts. So let's say I run fast, I run swiftly, I am a sprinter. All these things mean that I run fast, right? So they have very close relationship with each other. These are similar sentences. So coming back to this, what happens is user's query, what is the name of Harry's mother, gets converted to numbers. It tries to find out of all these 600 chunks that it has, it tries to find which are the top 3 chunks that have the highest probability of having an answer to this question. So the answer could be on page number 4, 28, and 36. And it could be on other pages also, but it will try to get the top 3 which are the closest, for which the semantic similarity, or there is a concept called Euclidean distance. So Euclidean distance is a number that is closest to the Euclidean to these embeddings. So out of these 600, only those 3 will come. And those 3, along with this question, will be passed to the LLM. And then from those LLM, I mean, in a way, those 3 chunks will be the text that we see over here in the primary content or the context. So this context, along with the question, what is the name of Harry's mother, goes to the LLM, and LLM finds an answer from it and provides the result to the user. Essentially, this is how retrieval augmented generation, or RAG, works. Okay. Now I will skip this. This is more about how things are deployed, but mostly this is a microservice architecture. You all must be aware of this. So yeah, these are some practical use cases we see. Yeah. Is there a question? Okay. In case there's no question, can you go on mute, please? Yeah, thanks. Okay, so these are some practical use cases that we see: creation of training data, chatbot to automate response query, customer queries, and all that. Report generation, marketing content, as we have seen. So this is where it generally generative AI is used. And what all technical skills do we require? So of course, we, apart from the typical generative AI knowledge, I mean, this slide particularly I had included because yesterday I was addressing the faculties at DY Patil. For them, I had prepared this slide because I wanted them to focus on these skills for their students, because generally students only focus on um, say the LLM part, the heavy lifting part, but these things which are equally important, if not more, when they come into the industry, it is very essential for the teachers to cover these in the college itself. So that is the reason I had included this slide, but this is more self-explanatory. Okay, so now let's get to the practical sessions. So are there any questions, Nandadeep? I mean, I can't see the chat.
Yeah, Mr. Agnes, in the chat there are no questions, but if in case someone has a question, please feel free to unmute and ask, or maybe type in the chat.
Hi, Kaustubh. This is Nitin. I have one question.
Yes, Nitin.
So while you're talking about the RAG, right?
Mhm.
You mentioned that we chunk the document and load it in the vector database, and
Correct.
we pass it to the LLM, right?
Yes.
So what is the role of LLM? So is LLM short-lived, or is it getting trained with the context there? How does that work?
No, LLM is not getting trained. LLM is only trying to complete the question. Okay. So,
Okay,
it is given this prompt and it is given a question also, right? So it is just trying to complete that by giving the answer. Okay.
okay. Yeah, yeah,
So to give you an example, I'll quickly give this very simple example. Okay.
sure.
Let's say I type this India, Delhi, England, London, right? France. What should be the word? Paris. Correct?
Paris. Yeah,
Okay.
yep.
So now, if you simply give this to an LLM, okay,
Mm-hmm.
LLM will give you the answer as Paris. Okay.
Correct,
So why does it do that? Because it is trying to complete this. It is predicting the next word. Okay. As I said,
correct.
that this is a language model. It is trying to predict the next word. So given this sequence, it
Mm-hmm.
is simply trying to predict the next word. It doesn't have the general
Okay,
knowledge that the capital
okay.
of France is Paris. It is only trying to complete
Mm-hmm.
because it has learned from the text corpus that somewhere this word
Okay,
France is related to Paris, and both these words have the same relation what England has with London, what India has with Delhi. Okay,
okay.
that's
Mm-hmm.
how it works.
Okay,
So,
got it.
so also
Yeah.
in this example, so
Mm.
the LLM processing this prompt, right? So how the LLM or where the raw data is stored in any AI model? Is it they use any database or what component it is called in AI era?
In LLM, it is called parameters. So you must have read this, right? That GPT is say 1. I don't remember the exact names, but sorry numbers, but it is 1.8 billion parameters. Then
Hmm.
something is in million parameters. Then the biggest one is in say 550 billion parameters. So that billion or the parameters is nothing but the knowledge that it has gained out of the free text that it is trained upon.
Okay, got it. Yeah.
Okay. Yeah.
Thank
I have one question regarding the vector database. So, can you explain what exactly you mentioned that the vector database it it tokenize some set of words and store that
Mhm.
number
Mhm.
in the database, right? Is that understanding correct?
Correct. Correct.
Okay.
So typically what happens is, I'll give you an example. Okay. King. So let's say there are few words. Okay. And then
Hmm.
there are about 512 columns which define every word. Okay. Now we do not know what these columns are. I mean, the LLM or the not the LLM, sorry, the embedding model does this implicitly. But for the sake of easiness of understanding, let's consider that I would say um, gender M, gender F, then royalty, acting skills, right? Palace, something like this, right? So let's say these are few dimensions. There could be
Okay.
512 more such, right? Now for a king, the gender is male, right? So this could be one, or this won't be one. It could be 0.85, for example. Gender F
Hmm.
is 0.15. Royalty is more again. Acting skills could be less. I mean, unless the king is an actor. Lives in palace, yes. Similarly for queen, this is very less. This is more, right? Royalty
Hmm.
is of course more. similarly to this. So what is the relation between king and queen? Most of the dimensions are same for king and queen, right? They both have royalty attached to them. They both live in palace. Only difference is the gender, right? So that means these two words are pretty close to each other. Similarly, actor and king, they both are male, but apart from the gender, nothing else is common, right? So an actor is closer to an actress because the only difference is in gender, but actor is pretty far from a king, correct? So in very simple terms, this is how it happens. So embedding model will give all these weightages against say 512 columns to each word, or in this case, it will do this for each chunk. Okay, so that's why there will be some relationship between chunk 1, chunk 2, chunk 3, whatever, right? So the question that is asked, say, let's say question 1, and we have, say, in this case, we have 600 chunks. So whenever a question is asked, it will try to find the semantic similarity that, okay, within these embeddings, which are the closest embeddings? So Euclidean distance is the distance between, or the difference between two text, two embeddings. So it finds that, okay, 1, 2, and 3 are the closest. So it will get these three as the context. It will get these three. It will pass it on to the along with the question to the uh, to the LLM, and it will give the answer. Okay.
So so when we talk about, I used to hear a lot of databases are vector database. So what it means that when we store the data in those database, it's convert into multiple dimension and assign a probability and store. Is it that what is happening? What it means?
Correct. Yes, yes.
Okay.
So what happens is that after the documents are chunked and embedded, all those embeddings are saved in the vector database. Okay, but this vector database is not a typical SQL or a no. This is a NoSQL, of course, but this is a special type of database. So this is not the typical relational database like Oracle or SQL, right? Examples are Pinecone, Chroma. These are few examples of the vector databases.
Okay, and where this vector database are used, basically in the Korean area. So, for example, when you use the Chat GPT, are we interacting with the vector database?
In case of Chat GPT, we are not. In case of Chat GPT, we are directly using the knowledge that is there inside the GPT. Inside the model, right? In this case, we need to, because we are using retrieval augmented generation, what we want to do is we want to do the generation, or we want to get the answers from our specific documents, right? So these documents, for example, are my confidential legal documents for my company, right? These are not available online, or these are not available publicly. GPT or any other LLM has never seen these documents, right? So when I want specific answers from my documents, I will save them in my vector database, which is away from the public domain, which is secure.
Okay.
Yeah. Okay. That's where we use vector databases.
Got it. Thank you.
Right. Okay. Now let's get to practical. So this is a Python notebook which is available on Google Colab also. So here what we are trying to do is that there is an image. This is an image of a backpack. If you see a plain sketch, and below this, if you see, they have shown some kind of, there are nozzles from which gas can be come out like a rocket, and it can go up, it can fly. And they have given some, just they have tried to label certain parts of the bag, right? So what we are trying to do is we are trying to create or let LLM create some marketing stuff against this image. Okay, so for that we will be using Gemini 1.5 Flash model. This is the name of the LLM. Okay. Now let's start. We first install these required libraries in Python. Meanwhile, let me open ChatGPT if I can. Completions. Okay. So let's say I ask who built Taj Mahal. I've run out of my limit. Okay, leave this. Okay, so this is installed now. I simply initialize all these libraries. I use my key. I initialize the model. So what I'm trying to say is that this should be the LLM that should be used for creating the content. Now this image is saved over here on this URL. Okay, so we are simply trying to we have got that image in the memory, and this is the image. Okay, now this is a prompt. This image contains a sketch of a potential product along with some notes. This is a product along with these are the notes. Given the product sketch, describe the product as thoroughly as possible based on what you see in the image. Make sure to note all the product features. Return the output in JSON format. So this is nothing but prompt engineering, if you remember, right? Very clear instructions on what is to be generated, very clear instructions on what should be the output format. Let's run this. And now we are asking the model to generate the response. Now let's see what kind of response has it generated. So if you see, this is in the JSON format, right? Description, the jetpack backpack is a backpack that looks like a normal backpack but has retractable boosters that allow the user to fly. Is powered by steam and is green and clean. It also features all of this, right? And after that, it has features and a list of all these features. So if you see, it has honored the prompt, it has given the result in the format that we have asked it to do, and it has described the product after looking at the image, right? So this is nothing but generative AI. It has generated this content. Now let's see what this prompt says, that you are a marketing whiz and writer trying to come up with a name for the product shown. Now it wants a name for the product. Now it also says that return the result in the array format like this. Pay careful attention to return the valid array in the format described above, no other text. The most important thing is to stick to the array format. So if you see, two or three times it is telling to have the output in the array format. Why it is doing so? Because this thing is very essential, the output format, and it has tied this output with a drop down control. Now if you see, these are all the names it has suggested for this product. It could be called a liftoff, it could be called a flight, airborne, skypack, eco drive, anything. You run this again and you will get a new set of names. Why? Because this is probabilistic. Every time it will come up with a new C. Few names might be same, but most of the names have changed. Right? Now, if you see that you are a marketing whiz, expert copywriter, it is telling that, okay, what the LLM has to do it has to come up with these suggestions. There should be a title or a tagline and a description. So it is giving examples that, okay, you need to give your output in this format when you should have a tagline like something like this and a description something like this. So let's see what has it come up with. Did we miss running something? Okay, seems there is some problem in the generation. So this is also one of the shortcomings of GenAI. I mean, at times you have to, in case this happens, then ideally we should be updating the prompt. See, now it has run, right? We didn't change anything. So in such cases might happen because again, this is probabilistic. In that case, we have to improve the prompt that we provided. Now, if you see, these are the 10 sets of H1 and H2, that is the tagline and description that it has come up with. Now we are telling it that, okay, this is what I define. Out of these 10, maybe I have decided to go with this set. Now generate an HTML for me. Again, in a way, this is code generation. And if you see, it will come up with the HTML output. Let's see how it looks. I'll copy all of this. Save as, let's say on a desktop. I'll say new HTML.html. I'll try to open this. See. Right, so it has actually generated the code for HTML through this prompt. Now, if we see, if I change the prompt a bit and I say, top level title should be red in color. Other text should be green. Let's see if it changes. Okay. Let's call it colored HTML. See, the title is red, this is green. So using prompt, you can make these changes. So prompt engineering, or the way you write the prompt, the way you give the instructions, the more clear, the clearer the instructions are, the better the output that you will get. Right. Now, I actually plan to show you one more notebook. I'm not sure if we have the time. We are already 4 minutes past. How is it? I mean, does everyone have say 10 minutes? I can continue.
Yeah, Kaustubh, please continue.
Okay, sure. So here we will try a retrieval augmented generation. So um, so we all have seen this movie Bahubali, right? Most of us at least have seen both the parts of Bahubali. What I've done is that I have created I simply copied the content from Wikipedia for Bahubali 1 and Bahubali 2, and I pasted that, created a PDF out of it. Now this is my document from which I want some answers to be generated, right? So what I'll do is I'll simply upload this in my sample data. Meanwhile, let's I will install all the required libraries. So the main fun over here is that you don't have to worry about the syntax. For example, what we saw now, to change the color of the title or the body, I don't have to remember the syntax or which attribute do I need to change in HTML. It automatically does that. You just have to give the prompt, you just have to explain the problem properly, and it does it on its own. That is the best part. Imagine this is a very, I mean, this HTML was a very simple one, but it can actually help in complex things also. And just imagine the level of, the amount of time that you will save with this.
Is there any score or something which can give us, tell us whether the prompt is good or bad, something like that? Or is
So
it
generally,
just by random or
yeah.
based on
So
the result?
generally, yeah. So generally, what we do is that the evaluation is very subjective. Okay. So in case of generation, we generally have a human in the loop to validate the results. So it is generally an SME, a subject matter expert, who would validate the result. Otherwise, one more way is that we get the ground truth text from the from the SME. So let's say, for example, we have a question: what should be the ideal answer as given by the SME? We get that, and then we let the LLM generate the answer. After doing that, we compare both the answers through this through by finding the semantic similarity between both of them. And if the semantic similarity is close enough, we tell that, okay, these two, I mean, the answer that is generated by the LLM is very close to the ground truth that is given by the human SME. Okay, so here what I did is that I imported all these libraries. I just initiated the Hugging Face API. Then through PDF loader, this is one of the libraries in Python, and LangChain is a library in Python which allows me to do the RAG. I have uploaded this file, Bahubali summary. Okay, and I just try to see what is the content within this. Now here I'm trying to chunk the content. So there were about 3 pages. See, length of documents is 3. There are 3 pages into this, right? Now these 3 pages I'm trying to chunk into 1,000 words each. So 1,000 words worth will be one chunk, and there will be an overlap. So the first chunk will be 1 to 1,000. Second chunk, because there is an overlap, it will be between 900 to 1900. Then it will be 1800 to 2800, that way. So using this, I have chunked all this, and if you see the number of chunks, those are 14. So for 3 pages, we have got 14 chunks of 1,000 characters each. And randomly, if we see what is there in split 4, this is what is in the fourth chunk, right? Now I'm initializing the embedding model to convert each of these chunks into embeddings. So here you will observe that the results that you get, okay, see, sample embedding. This is an embedding for one of the chunks. So here I've given chunk number 4, the page content, what we just saw above. For this chunk, this entire text is represented in this manner. These are the embeddings. Now I'm putting all of this in a vector store. FAISS is a type of a vector database. What I'm saying is that I need to create a vector database from documents, docs after split. These are all the chunks, and Hugging Face embeddings. This is the embedding model. So using this embedding model, I need to embed all these chunks and then store it in the vector database. Then I initialize a retriever. Retriever means, again, from the vector store, what we just discussed, right? That for the given question, there should be similar chunks that should be found out and sent to the LLM as the context. So here I give k is equal to 3. That means the closest 3 chunks should be identified. I can give 4 also, 5 also, but that might increase the token size and it might fail when we call the LLM. Now here I'm initializing the LLM. I'm using Mistral 7B version 0.1. 7B means this is Mistral with 7 billion parameters. Now, mind you, this is an open source. This is a free model that is up to use. So definitely the performance may not be as good as GPT-4. GPT-4 might be, I think it is 550 billion or something. So way large than this one, right? So let's say we have a query like, what is the name of Shiva's mother? Okay, it should give me the answer from this document. Now there is a prompt which says that, okay, use the following piece of context to answer the question. This is a typical prompt like we saw there. Given a context, question, and what is the answer? Now let's see what kind of answer it gives us. See this. It says this is the context that it has found. These are the 3 contexts. This is 1, this is 2, and this is 3. 3 chunks it has found where there is a high probability of finding a name for Bahubali's adoptive mother. This is the question and this is the answer. Now, I'm not sure why this is coming multiple times, but again, with a better, I've tried this on GPT 3.5 Turbo and it simply gives me one word answer, Sangha. Sangha is the name that is mentioned over here. See this, the child is saved by the people. The wife of the tribe's chieftain Sangha decides to adopt the boy. Now, it is nowhere explicitly mentioned that she is the mother. It only says that she adopts the boy. And which boy? Then the child that is saved by the people of this tribe, right? So, but it has implicitly made that relation and it has found out that, okay, this seems to be the mother. Now let's try asking a slightly different question. So now I will ask, what is the name of Bahubali's grandfather? Why does... Okay, what is the name of Bahubali's grandfather? Give justification to your answer. Okay. Now, nowhere is it mentioned who is the grandfather of Bahubali, right? In the document. but let's see if it gives the right answer. Okay, so the name is Vikramadeva. Justification it doesn't give, right? I can quickly show you how the response appears on with GPT 3.5 Turbo. Okay, because this is important. It is because I want to show you the reasoning capabilities of it. So this is a saved notebook. I won't be running this, but for this I had used the databases from my office. Sorry, the subscription of my office, and it was a better LLM, of course. So see the same question: what is the name of Bahubali's? Give justification. It says the grandfather's name is Vikram Deva. This can be inferred from the context that mentions that Vikram Deva is the father of Amrendra Bahubali, who is Bahubali's father. It is also mentioned that Vikram Deva died before Amrendra Bahubali was born. Okay, so it is giving the justification also. It is giving, there is some reasoning also within LLM. It is not that it is just finding a keyword search and then doing this. No, it is employing some brain, some logic behind, justifying that why is this the grandfather's name. It is nowhere mentioned explicitly in the document, right? Now look at this answer also. Who is the antagonist? Who is the villain in Bahubali? Please explain with reasons. So the antagonist is Bhallal Dev. He's the main rival, constantly trying to undermine and overthrow him. Okay, he's power hungry. He does everything to become the king and all that. So the point I'm trying to make is that this is not simple keyword search, but it is a more semantic, it is a more cognitive, it is a more intelligent search that happens, wherein the context is retained. There is a reason given why it has, and this also comes as the explainability. So how should I trust the output of an LLM? This is making me trust it because this is giving me the correct justification why it has come to a particular answer, right? So yeah, so this is what essentially what I wanted to show to you today. With that, I'll take a pause. I come to the end of what I had planned for today. So we are open for questions now.